Hello, welcome to Maitri Vidya YouTube channel. So in this video, we are going to find the equation of tangents to a given circle with a given condition. So we are finding the equation of tangents means basically we are finding the equation of a straight line, and that should be a tangent to the given circle, okay, and with the given condition. So we will be having two types of condition here. So whenever the slope of the tangent is given, so we need to find the equation of the tangent to a given circle. So one more condition will be whenever the equation to find the equation of the tangent, we need to we will be having a point, okay, will be given. Okay, so that means for a given circle one point will be given, so we have to draw a line through that point so that uh, it should be a tangent to the given circle. So those are the two things we are going to discuss now. Okay, so let me discuss the first condition whenever slope of the tangent is given. So now we know that equation of a tangent means we are finding the equation of a straight line, so that is becoming tangent to the given circle. Okay, so to find the equation of a straight line, we require two things. So that is one is slope, another one is a point. Okay, so with the help of these two, we can find a equation of a straight line. So only the one thing is given, the slope of the tangent is given here. Okay, so the point is not given. Instead of giving the point, as he has given one condition, that the condition is uh, with this given slope we have to draw a straight line such that it should become the tangent to the given circle. Okay, tangent, so that is the given condition here. Okay, so observe this, we can draw with a given slope infinitely many number of straight lines. Okay, so let me select this straight line here. I have selected, and without changing its direction, so that is the meaning of not changing the slope. So that means I can move this line parallel to this. Okay, so I can I'm not I can say that I'm not changing this equation slope of this straight line. Okay, why? Because I'm moving parallelly to this given straight line. Okay, so in that way I can draw so many infinitely many number of straight lines here like this. So out of all these straight lines, exactly, okay, two straight lines. So one is at this place and another one is at this place. Will become they will become tangent to the circle. So now we are going to find those two straight lines equations. Okay, so that is nothing but equation of tangents to the given circle. So with a given slope. So with a given slope, we can draw infinitely many number of straight lines. But out of all those straight lines, only two will be the tangents to the circle. So we are going to find the condition to find the uh, so the condition is given. Okay, that is the tangent condition. So we are going to find the equation of the straight line. So that which will become a tangent to the given circle equation. So let us assume that the equation of the straight line, the tangent, or otherwise tangent, I can say. Let me bring this straight line at this point so that it look like a tangent to the circle. So now I will assume that equation of tangent is y is equal to mx plus c. So now I cannot change the value of m. Why? Because it is fixed. So that is the meaning of moving the straight line in parallel manner. Okay. So the m is fixed here, but we don't know the c. C is a y-intercept of the straight line. Okay. So here you can observe the point that is a y-intercept of the straight line. So I am naming this point as A, and it is having the coordinates 0 comma c. Okay, so if I move this straight line, okay, if I move this straight line parallelly, so the value of c is becoming the value of c is changing, okay, accordingly. So you can observe that the intercept made by the straight line on the y-axis, so it is changing. As this is changing, the value of c is changing. So for particular value of c, so it is becoming the tangent to the circle. So now we are going to find that c value here. So using the condition that, so the straight line is becoming the tangent to the given circle. So let us assume that the given uh, s- circle equation x square plus y square is equal to r square. So this is the simplest form of the circle whose center is 0 comma 0 and radius is r. Okay, this is simplest form of a circle. So why I have taken this simplest form of the circle means by finding the condition to the c, I will expand this. I will similarly I will write the same type of equation for the other formats of the circles also. So now this is the circle equation: x square plus y square is equal to r square. Okay. So the center of the circle is 0 comma 0, as we can sense from the uh, diagram also, that is the 0 comma 0, and the radius of the circle is small r. Okay. So whenever a circle is touching the so whenever a line is touching the circle, so I can say that the distance between the center of the circle to the straight line must be equal to the radius of the circle. Okay. So now what I have to do is I have to drop a foot of perpendicular from the center of the circle to the straight line. So that is nothing but r. That should be is equal to radius of the circle r. That should be nothing but radius of the circle r. So now I will try to apply that condition r is equal to d here. So where r is the radius of the circle and d is the distance from the center of the circle to the straight line. So d is equal to distance from center of the circle to straight line. So the distance formula will be d is equal to mod of ax1 plus by1 plus c whole divided by under root of a square plus b square. So we can analyze this formula, distance formula, from a point to straight line in this way. So let me take a straight line. If I have a whose equation is ax plus by plus c is equal to 0, and I want to find the distance between a point x1 comma y1 to this straight line. So I have to drop a foot up perpendicular from this point to the straight line, and I have to find the distance between this foot up perpendicular on this straight line to the given point. So that is nothing but the d. So what we have to do is the distance formula is in the expression, so which is representing the straight line equation. We have to take that expression So in that expression, we have to substitute the x and y values. Okay, the x coordinate and y coordinate values of the point in the place of x and y. Okay, in the given straight line expression. So divided by under root of x coefficient, that is a square, plus y coefficient square. So I'm going to apply the uh, same thing here. I have the from the above diagram. So the straight line look like this. So here somewhere I have the origin. So that is the center of the circle. From this, I have to find the distance. Okay. So the distance to the equation y is equal to mx plus c. So the y is equal to mx plus c can be written as mx minus y plus c. The same equation can be written in this format also. So now I will apply the above concept. So what I have discussed, okay, here, okay, to this situation, I will get the d value. D is equal to, substitute the 0 comma 0 in the place of x and y in the given expression, that is mx minus y plus c. So d will be equal to mod of m into 0 minus 0, in the place of I have written 0, plus c, whole divided by under root x coefficient, that is m here, m square, plus y coefficient is minus 1, so whole square. So now the d value is equal to, d is equal to m times of 0, it will become 0 and 0, and divide plus c, it will be mod c in the numerator, divided by under root of m square plus 1. So this is the value of d I will be getting. So now this should be equal to the radius of the circle according to the tangent condition to a circle. Okay. So what I have to do, I will equate this to the radius of the circle. Radius is equal to distance from the center of the circle to the straight line. So R will be equal to mod c divided by under root m square plus 1. So transpose this denominator to the left hand side. I am going to get mod c is equal to, okay, r times of under root m square plus 1. C will be equal to, uh, if I can take off this mod value, so I have to put plus or minus sign to the right hand side. So plus or minus of r times of under root m square plus 1. So this is the value of c. So I have assumed that equation of the tangent is y is equal to mx plus c. Okay, instead of c here, I can write c value as plus or minus r times of m square plus 1. Okay, so mx. So instead of c here, I'm writing that plus or minus of r times of m square plus 1. But this is the equation of the tangent. So as we observe here, we have got plus or minus sign here. So if we observe from the diagram also, we can feel that. So there are two tangents possible. Okay. Okay. One is here. The another one is here. Okay. So for this tangent, the value of c will be here. Okay. So that is why I'm getting the plus or minus sign here. Okay. So now let me rewrite this equation here. So why? Because with the given slope, okay, so we can draw two tangents to a given circle. Okay. So one plus sign corresponding to the one tangent, the minus sign corresponding to the other tangent. So I have a tangent here. So let me select this tangent. So if I move this tangent, okay, it is becoming a secant to this circle now. And again, if I move further and further, so at this point again, so it is becoming the tangent, the same, the straight line with the same slope. Okay. So we have the two tangents now. So those two tangents, okay, are corresponding to this plus or minus sign. Okay. Plus sign is for one tangent, minus sign is for another tangent. Okay. So now we have got the equation of the tangent with the given slope m to the circle x square plus y square is equal to r square. So this is the equation of the tangent to this particular circle. Okay. So this is tangent to circle equation x square plus y square is equal to r square. So let me write this equation of tangent, okay, in this format. Let me write in this way. So this is a y I am writing as y minus 0 is equal to m into, instead of x I am writing it as x minus 0 plus or minus under root of r times of under root of m square plus 1. So if you observe here the 0 and 0, okay, so the 0 comma 0, it is the center of the circle x square plus y square is equal to r square. So this is the radius of the circle. Okay, I just wanted to highlight these. Why? Because I'm going to extend this discussion to the circle with the center h comma k. Okay, let us assume that. So the given circle equation is, okay, equation of tangent with slope m to the circle x square, not x square. Actually, it should be x minus h whole square plus y minus k whole square is equal to r square. So this, for this, I can directly, okay, from the above equation, I can directly say that the equation of tangent is y minus y coordinate of the center of the circle, that is k. Okay, so that is a y coordinate of the center of the circle k. Y minus k is equal to slope of the tangent, that is m, into x minus x coordinate of the center of the circle, that is h, plus or minus r into under root of m square plus 1. So both are looking like similar equations. So here k and h and r is highlighted. Why? Because h comma k is the center of the circle x minus h whole square plus y minus k whole square, and r is the radius of the circle. So for this equation of the circle, so we can draw a tangent. We can draw two tangents with the slope m. Okay, so what are those two tangents? These are the two tangents. Plus is for one tangent, minus sign is for the another tangent. So let me discuss one more format of the circle equation. So equation of tangent to not to equation of tangent with slope m to the circle to the circle. So I'm taking the circle equation, the general circle equation here, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0 now. So for this circle, I know that the center of the circle is minus z comma minus f. Radius of the circle is, let me write the center first. Center of the circle is minus z comma minus f, and radius of the circle is under root of g square plus f square minus c. So after finding these two, I can apply the same above concept what we have discussed so far. So to this okay situation, so I can write the equation of the circle. So in this equation of the tangent, sorry. So in this way, y minus y coordinate of the center, that is minus of, that is minus of is equal to m into x minus x coordinate of the center of the circle, that is minus g, that will be minus of minus g plus or minus r into under root of m square plus 1. Okay, so let me rewrite this, let me simplify this equation. Y minus of it will become plus f. Y plus f is equal to m into x minus of minus g, it will be plus g, x plus g plus or minus r into under root of m square plus 1. So I can say that this is the equation of the equation of the tangent to the circle, okay, which is in the format of x square plus y square plus 2gx plus 2fy plus is equal to 0. So we can remember these formula of the equation of tangent. Okay, so if we observe this logic, okay, so they are easy to remember. So even if we don't remember the formula, so we can always apply the condition. So the tangent condition, what is the tangent condition? R is equal to D. Okay, the distance from the center of the circle to the given straight line, so that is the D, should be equal to the radius of the circle. So then we can say that the straight line is touching the circle. Okay, the straight line is touching the circle. So while we solve a problem, example problem based on this concept, we will solve the we will try to find the equation of the tangent. So with the help of the formula, and as well as by applying the concept r is equal to d, that is a tangent condition, r is equal to d. So in both ways, we will check the equation of the circle, whether it is correct or not, whether it is so whether we are getting the same answer or not. Okay, so that's in this video. That's it for this video. So I hope you have understood very well the equation of the tangent whenever the slope of the tangent is given. How to find the equation of the tangent. Thank you very much.